You've spent thousands of dollars on your home cinema equipment, but do you actually know what it's doing in your room? Whether you're a professional designing complex DSP filters, a beginner wanting to measure your room for the very first time, or an enthusiast who relies on automated premium calibration systems like Dirac, you all share a massive blind spot. You don't actually own your raw acoustic data. Measuring a standard 5.1 or 7.1 bed layer in REW is a mostly solved problem. But the moment you want to capture the spatial impulse response of your Atmos speakers, like ceilings or front wides, or you need to discretely measure multiple subwoofers through your AVR, Windows Audio hits a brick wall. LPCM simply caps out at 7.1. Historically, we've had to rely on miserable workarounds. You're either dealing with ASIO wrappers that crash, setting up clunky analog loopbacks, or physically swapping pre-out cables on the back of your rack for every single sweep. If you followed the channel, you might remember the playable Atmos sweeps I built in the past for REW's file play feature. While they gave us a path forward, let's be honest, they required a massive learning curve. You had to learn the entirety of REW framework, execute flawless measurement processes, and perfectly route your audio interfaces without a single mistake. But here's the real kicker. Even if you jumped through all those hoops and mastered the workflow, there are two hidden acoustic traps baked right into home theater hardware that permanently corrupt your data. And until now, standard tools simply could not fix them. First, the Dolby volume offset. In commercial cinemas, top, middle, and side surround speakers are massive arrays, but at home, they are usually just a single pair. Because of this, Dolby embedded a permanent volume difference into these specific channels for home theater decoding. If you run standard sweeps, your measurements for those channels are inherently skewed. Second, the subwoofer LPF trap. Most AVRs absolutely refuse to bypass the low-pass filter on the LFE channel during measurements. This artificially rolls off your high frequencies during the sweep, permanently ruining the raw bass response and phase data you desperately need for proper subwoofer integration. I got tired of the miserable workarounds. I got tired of the steep learning curves and the hidden inaccuracies. And so, I built a solution to solve this fundamentally. The software offers state-of-the-art accuracy. It utilizes the Novex exponential synced sine sweep convolution method, which provide the highest precision phase extraction available. It features precise clock drift and relative timing calculations using dual acoustic timing reference chirps. The first chirp measures relative speaker distance, while the second measures clock drift, achieving an impressive accuracy down to 1 part per million. It also ensures the mathematically perfect removal of the subwoofer low-pass filter effect. It uses the minimum phase version of your microphone calibration files for ultimate accuracy in phase response. Since microphone calibration files are inherently just frequency magnitude responses, they have their own phase deviations, which GSonic takes into consideration. Spatial averaging uses Gaussian mic position distance weighting while retaining the phase response of the main listening position for all speakers and subwoofers. This provides an average that best represents your in-room speaker response, allowing you to properly time align your subwoofers with your speakers and determine your crossovers. It offers sub-sample speaker time alignment accurate down to 0.36 millimeters. Here are the AVR settings you need before starting your measurements. If you're measuring your system without any prior calibration, apply these settings to the HDMI input port connected to your PC. If you plan to enable any AVR sideroom correction processing, like Dirac, Odyssey, or YPAO, set the AVR sound mode to stereo. For example, on a Marantz receiver, you do this by pressing the movie button and changing the mode to stereo. The system will then automatically switch to Atmos and True HD when needed. Do not use pure direct or direct modes unless you are only measuring your front main speakers. Other channels will not work in pure direct mode. Keep it in stereo and let the AVR switch formats automatically. Set all speakers to large or full range so that no crossovers are active. Reset all speaker distances, subwoofer distances, and volume levels to their default value of 0. Additionally, disable double bass or LFE plus main, depending on your AVR model. For the LFE low-pass filter, set it to the highest possible value if you cannot bypass it completely. Whether you bypass it or set it to a specific value, you must select that corresponding option in GSonic so the software can reverse the filter's effect. Turn off lip sync and echo mode. Echo mode can introduce unwanted effects, especially at lower volumes, so it must be disabled. While I haven't seen lip sync cause major issues, it likely introduces timing inaccuracies, particularly when a TV is connected. If you're using GSonic purely to measure post-calibration performance, use the quick one-position measurement while all your AVR room correction settings are active. This allows you to easily verify your calibration results. Next, let's cover the Windows settings. Your AVR must be recognized by Windows, though it doesn't need to be set as the default playback device. The same applies to your microphone. Ensure that Windows spatial sound is turned off, as this disables crucial pass-through audio features. Send a simple stereo test tone to confirm Windows is playing sound through your AVR. If Windows can't play sound, GSonic won't be able to either. Finally, make sure the speakers are set to full range in Windows. In the advanced sound settings, set the sample rate to 48,000 Hz for both your playback device and your microphone. You can choose 24-bit depth if you prefer. Under exclusive mode, ensure both allow applications to take exclusive control of this device and give exclusive mode applications priority are checked. Lastly, check the box to disable all enhancements. Once configured, these settings will persist as long as you maintain the HDMI connection. If you're using a UMIC microphone, make sure it is recording at the correct gain level in Windows. If the gain is too low, you might encounter signal issues. Setting the microphone volume is something you'll need to manage within your computer's OS, as GSonic cannot control hardware gain levels. Now let's look at the GSonic app itself. First, select the output folder where your measurements will be saved. Next, load your mic calibration file. GSonic can read calibration files for UMIK, Earthworks, and many others, including reading the sensitivity data embedded in USB microphones. It can also process all kinds of Odyssey microphones. You will find a link in the video description for the generic Odyssey mic calibration file if you are going to use the bundled mic that came with your Denon or Marantz receiver. Choose your number of mic positions, 1 for a quick check, 3 for the default, and up to 16 for a comprehensive spatial measurement of your room. Next, enter your AVR's low-pass filter, LPF or LFE setting, so the software can reverse its effect. Options include 200 Hz, 250 Hz, 320 Hz, or bypass. GSonic will save 10 decibels boosted raw measurement of your subwoofer, as well as its reverse low-pass applied and volume-corrected version for the main listening position. And select the specific speakers in your layout. The app lists standard naming conventions for all channels. For example, in my setup, I select FL, front left, FR, front right, surround left, surround right, top front left, top front right, rear height left, rear height right, and one subwoofer. You cannot uncheck the front left speaker as it serves as the acoustic timing reference. Everything else is flexible. The software supports up to 4 subwoofers. Note that when measuring multiple subwoofers, you will have to manually turn them off and on during the process. The app will remind you when to do this, as it's the only way to accurately measure individual subwoofer volume. Next, choose your audio input and output devices. In most cases, the system will automatically detect your HDMI output, unless your PC has multiple HDMI ports. Be sure to verify your microphone input, since Windows may default to a webcam or an internal mic. If you change any of these settings, remember to click Refresh Devices. You can also play a test tone here. It confirms that audio is being output and that your microphone is receiving it. A dedicated subwoofer test tone isn't included, as properly setting subwoofer levels is more complex than what narrowband pink noise can accurately represent. After taking a quick single position measurement at your listening spot, you can import the measurement files into REW to determine the precise volume offset needed for each subwoofer. Apply those offsets, then proceed with your next round of measurements. The mic centering tool helps you perfectly position and center your microphone at the main listening position. Once everything is set up, your configuration will be remembered for future sessions, so this is just a one-time process. Simply click Start Measurements. The software will measure every speaker one by one, save the data, calculate a perfect spatial average of all measurements, and generate an ADY file formatted for acoustic analysis. If you have a Denon or Marantz receiver, GSonic will detect it automatically. It will not generate an ADY file for other brands to avoid confusion. Regarding mix centering, if you are using an analog microphone, including Odyssey mics, you can adjust the placement in real time very precisely without needing to look at your monitor. Since it's difficult to see your computer screen from the MLP, the app uses audible pitch cues to help you easily center the microphone blind. With USB mics with no internal clock, like the UMIC one, clock drift makes real-time centering a bit trickier. They might show stability issues during the centering process, though not during the actual measurements, which remain highly accurate thanks to the acoustic timing reference, ATR. Since ATR cannot be used during live mic centering, highly reflective rooms can cause sharp bounces. Ultimately, exact mic centering isn't critical for measurement accuracy. It primarily affects distance calculations and helps avoid comb filtering during stereo measurements, since Denon and Marantz AVRs, like most others, calculate distance in 1 cm increments but 3 cm accuracy anyway. Obsessing over millimeter perfect placement is unnecessary. Once your measurements are finished for every position, data for each individual speaker is saved in a time-stamped folder. There is also an averaged folder containing the automatically calculated average responses. These are saved as standard WAV files, which you can drag and drop into any measurement program, including REW. The measurement log file provides subsample precision peak arrival times in milliseconds. This shows the exact distance delays for all your speakers relative to the front left channel. The data is provided in milliseconds because older Denon and Marantz models assume an incorrect speed of sound, 300 meters per second. Providing the data in meters or centimeters would cause calculation errors for those users. You will need to convert these accurate millisecond delays into feet or meters, based on the specific speed of sound your AVR model uses. The log file also provides speaker loudness levels. Note that this is calculated as an RMS value from 300 Hz to 3000 Hz. While it isn't a highly precise loudness metric, it gives you a solid ballpark figure of volume differences relative to the front left speaker, along with file path details. When you import the WAV files into REW, you will see familiar measurement graphs. Receiver, you will also see a generated ADY file. As you can see, this is a fully compatible ADY file utilizing 16,384 sample measurements, downsampled from the original 131,072 tap captures. That's basically it. You may have issues setting up Windows Audio and your AVR correctly for the first time if you have never done this before, but once this is done, and these settings are persistent, you can take measurements of your full system with the click of a button whenever you need. You can find the link to purchase GSonic Immersive in the video description below. For issues, you can contact me through Gumroad or write a comment under this video, and I will get back to you as soon as I can. In the case of any technical issues, don't forget to share your debug log, which can be found under your username folder on your PC where the app is installed. Have fun using the software and taking measurements.